So in today's video, I'm basically just going to be taking you guys through all of the FRQs that you are probably going to have to do on the exam. Basically, 5 out of the 6 FRQs on the exam are basically the same exact thing on AP Calculus every year. So that's enough talking. Let's just get straight into this. So in this first question, we're usually going to be given a table, okay? So in this one, we're told the density of a bacteria population in a circular petri dish at a distance r centimeters from the center of the dish is given by an increasing differentiable function f, where f of r is measured in milligrams per square centimeter. Values of f of r for selected values of r are given in the table. And then it tells us in part A, use the data in the table to estimate f prime of 2.25, and then it says using correct units, interpret the meaning of your answer in the context of this problem. So this is probably worth 2 points. Keep in mind every FRQ is worth 9 points, so we'll probably get a point for getting the correct number and then a point for getting the correct interpretation. So how do we estimate f prime of 2.25? Well, we're just going to use the average rate of change between these 2 points because that is where 2.25 is in between. So I would do 10 minus 6 over, then I would do 2.5 minus 2, right? So I would get 4 over 0.5, which is going to equal 8. Now I need to use correct units to interpret it, and I could say that this equals f prime of 2.25. And so now I could use correct units to interpret the meaning of my answer. So I'm actually going to type this. So what would be the units of the answer? Well, the units of the answer are going to be milligrams per square centimeter per centimeter. When you're doing units of a derivative, it's just y over x. Okay, so what we would say is it looks like at r equals 2.25 centimeters from the center of the dish, we would say so f of r would be represented by the bacteria population. So the bacteria population in the petri dish is increasing by 8 centimeters, and then now we have to do the units. So that's literally just y per x. So by 8 milligrams per square centimeter per centimeter. Okay, so again, it's just y, which was milligrams per square centimeter, per x, which is per centimeter. Okay, so that would be our answer to part A. Now for part B, it asks, the total mass in milligrams of bacteria in the petri dish is given by the integral expression 2 pi 0 to 4 of r f of r dr. And then it tells us to approximate this value using a right Riemann sum. So you are definitely going to be asked to do a Riemann sum on the exam. You might be asked to do it on a no calculator question. If you do, you should be very, very disappointed, because sometimes you're going to have to do Riemann sums that are going to take a lot of addition, and then it is a little challenging because there's an opportunity for you to add or multiply or do something incorrect. Here we know that the calculator has us covered. Now, we need to be careful because this Riemann sum includes an r. Usually a Riemann sum is just the integral of f of x dx, right? But here we also have an r. So it doesn't really change that much, except we're just going to have to multiply by the r every time. So what we would do is for a Riemann sum, remember that specifically for the right one, you're going to take each subinterval. So let's say this one, which has a length of 1, and you're going to multiply the length of that subinterval by whatever the right value is. So then for the 1 to 2 interval, the right value would be 6. So we do 1 multiplied by 6. Then for the 2 to 2.5, the interval length is 0.5, and we'd multiply that by 10. And then for 2.5 to 4, the interval length is 1.5, and we multiply that by 18. But we also have to multiply each of these intervals by their respective r value. So what I would then do is I'm going to go and do 2 pi on the outside, and I'm actually going to write times the integral from 0 to 4 of r f of r dr. And that's going to equal, I will have 2 pi on the outside, and then let's make this a bracket, and then I would have, okay, so I would have, let's put the r out in front first so we don't forget it. So the r for the first subinterval on the right is 1. So 1 times the length of that subinterval is 1, so times 1, and then we multiply that by the right number, so by 2. And then so for the next interval, we would multiply 2, because that's the r value, times the length of the interval, which is 1, times the right f of r value. And then so for the next one, it's going to be plus 2.5 times the length is just 0.5 times 10. And then finally plus 4 times the interval length is 1.5 times the right value is 18. And so now we're going to put this straight into our calculator. I'm going to leave the 2 pi out because we could like get our answer in terms of pi, but it'll probably end up just being easier if we just leave it out. So, and then multiply it at the end. So 1 times 1 times 2 plus 2 times 1 times 6 plus, then we have 2.5 times 0.5 times 10, and then plus 4 times 1.5 times 18. And then we would multiply all of this, 134.5, we'd multiply all of this by 2, right? That's this 2. So our answer would be 269 pi, okay? And does it tell us to interpret it? It looks like the answer there is no. So we would just say it is 269 pi over 3. And if you really want what the interpretation of a integral would be the y times x. So this would end up being milligrams per centimeter, I guess. But we do not have to interpret it. So for the next part, we're asked, is the approximation found in part B an overestimate or underestimate, and explain our reasoning. So what I always like to do for these is, before I even try to make an idea, let me just draw what this function might look like. So I would draw that this function would have 0, 1, then 1, 2, then 2, 6, then 2.5, 10, and actually let me make these a little lower so that it's a little better. And so what it looks like is happening is it is increasing like this, okay? And even if it wasn't increasing, and I'm trying to make this look like it should be exponential. So even if it wasn't exponential, even if it was just increasing regularly, it doesn't matter, because what you're going to notice is these right intervals are going to be larger than the left ones, okay? And because of that, if you just draw it, it's going to be an overestimate. Now again, even if you had drawn this, it just says that it's increasing. So if I just draw it like this, then we can tell that our right subintervals are going to be larger. Okay, so I would write, this is an overestimate. So let's change the font here. So my approximation in part B is an overestimate of the total mass of bacteria in the petri dish, because f of r is an increasing function, and therefore the right values for each interval are larger than the left values, which you could honestly just end it there, that you don't want to over explain anything. So your approximation in part B is an overestimate because f of r is an increasing function, and therefore the right values for each interval are larger than the left values. All right, so that's kind of all you have to say. So yeah, next, we're told the density of bacteria in the petri dish for 1 to r to 4 is modeled by the function g, defined by this. It says, for what value k, 1 to k to 4, is g of k equal to the average rate of g of r on the interval? So what is the average rate? Well, the average, where is that? So the average value of g of r, that is just any average value. So any average value of f of x, so f average of f of x, is going to equal the integral from a to b of f of x dx. But then you're going to multiply it by 1 over b minus a, or divide it by the interval length. So what I would do here is I need to set 1 over, what is the interval length? It looks like it's 3, right? 1 to 3 to k, right? Or 1 to 3 to r. This is really the interval length we're using. So 1 over 3 times the interval, or the integral, from 1 to 3 of g of r, and I want that to equal g of k. Okay, and so how can I figure this out? Well, what I'm going to do is, let's first find this integral. So 1/3, and this, by the way, should be 4. So 1/3 times the integral, and you can get that just by typing in int into the computer. So 1 to 4, and then g of r. So you would do 2 minus 16 cosine of 1.57 square root r, and then end all of this, and then cubed, right? And then make sure that you are in radians, and you get a problem, right? And what is this problem? It's that the calculator does not know what r is. So all you have to do is simply just change it to x, right? And then we should put a dx at the end. And it should give us our answer, right? And it's not. So why is that? Well, it actually might be because we need to put this in as a integral here, right? So let's see what happens if we put in, right? Yeah, so I think the problem is that I'm not putting this inside of parentheses, right? So let's put this into parentheses and see what happens, right? So we do get an answer, right? So again, also make sure you're putting this into parentheses, right? So what we would do here is this is what we need g of k to equal. So I'm just going to say equals 9.87579. Don't round too early. And so now all I have to do is just say, okay, when does g of k equal this? So I'm just going to write, when does 2 minus 16 cosine of 1.57 times, or 6 times 16 cosine of 1.57 square root x, and then let's cube this, cubed, and I want to know when that is going to equal this. So when that is going to equal this. So let's take a look, right? So it looks like it's going to be at some arbitrary value, right? So what do you do when this happens? Well, usually on the exam, you can click on this, but sometimes it doesn't allow you to do that. And the reason why is because in order for us to do that, we need to isolate x, and we don't have time to do that, right? That is a big waste of time. So there's a couple different ways you can do this. The easiest way is if you have a TI-84 plus CE, you can click this math button and then click this arrow and go to numeric solver. This specific calculator is not going to let me do it just because it's blocked on this website. But if you go in there, you can then just type in like this side of the equation, then you'll click enter, and then you would plug in this side of the equation and click enter, and then you click graph twice and it'll come up with a box next to the answer. Now, if you don't have that calculator, all you have to do is you would just say that this equals y, and then you would just write that this also equals y, and then you would find the x value that they touch. So there we would just say, okay, at what x value do they touch? It looks like it's 2.497. And you would say, okay, well, why is it not this one? Well, it says 1 to k to 4. So we would say, okay, well, k equals 2.497. Okay, and so that is all we have to do. All right, so that wasn't too bad, right? But the next one is going to be even easier than that. All right, so for this next one, it says from 5 to 10 a.m., the rate at which vehicles arrive at a certain toll plaza is given by a of t equals 450 square root sine of 0.62 t, where t is a number, or is the number of hours after 5 a.m. and is measured in vehicles per hour. Traffic is flowing smoothly at 5 a.m. It says, write but do not evaluate an integral expression that gives a total number of vehicles that arrive at the toll plaza from 6 a.m. to 10 a.m. And so all we have to do here is we would just do, this is an accumulation problem. This is the second problem you are likely to see on the exam, and this is most of the time going to be in the calculator section, right? So all we have to do is you integrate the rate at which something is going in order to get its accumulation, in order to get the total number that it increases or decreases. So we're given here the rate at which vehicles arrive. So all we have to do is integrate this value. So literally you get the point for just writing the integral from 1 to 5, because it asks us to go from 1 to 5, of a of t dt. You literally don't even have to write this all the way out. You can, if you want, you could write the integral from 1 to 5 of 450 square root sine of 0.62 t dt, but you don't even have to do that, right? This would be 0.62 t dt, but you don't even have to do that. Now, then, the next question, it says to find the average value of the rate in vehicles per hour. And so what is the average value? Well, we want to find the average value of the rate. So you might start getting confused. Well, what's the average value of the rate? I don't know. Is that going to be my average rate of change? Is that going to be my integral? What is it? Well, we're finding the average value of the rate, but we're given the rate. So we're basically finding the average value of this. And to find the average value of a function, you do the integral okay? So if we were given the number of vehicles and then asked for the average rate, then we would use slope formula. But if we're given the rate and then we're just asked to find the average value of the rate, it's basically saying find the average value. So here we're just going to do the same thing we did in the previous question. It's going to be 1/4 because that looks like our interval. 1/4 times the integral from 1 to 5 of, then we could just write a of t dt, okay? And so then I'm going to take this into the calculator and I'm going to do 1/4 and then integral from 1 to 5 of, and make sure you put your parentheses, so 450 square root sine of 0.62, and also don't forget that you should put x, it doesn't know what t is, dx, okay? And we get this number, right? So this is the average value of the rate in vehicles per hour. Okay, so here we would say, okay, it's 375.54, and what is it? It's vehicles per hour, okay? And again, make sure that you are in radians, right? We do radians for this class, all right? And so far, this is pretty easy. This is what we're on part B now. We've probably earned, you would probably earn 1 point. I think you actually earn 2 points for this. You earn on this question literally just a point for the bounds and then a point for putting the A of t. And then on this question, I'm pretty sure you get a point for the setup and then a point for the actual answer. So now we're at 4 out of 9 points, right? And so now it says, is the rate of vehicles, or is the rate at which vehicles arrive at the toll plaza at 6 a.m. t equals 1 increasing or decreasing? Give a reason for your answer. So we're literally just asked, is this function, because again, this is the rate, is this increasing or decreasing? Literally all we have to do is we would type into our calculator a of x, we should actually write a lowercase of x equals, and then you could write 450 square root sine of 0.62x. And then all you would do is you write a prime of 1, and it's going to give you a number. A prime tells it that it's a derivative. So in here, what would I write? I would literally just write a prime of 1 equals 148.9. And so is it increasing or decreasing? Well, this is greater than 0. So I would write, let's see. So I would write, since a prime of 1 is greater than 0, the rate at which vehicles arrive at the toll plaza at 6 a.m. t equals 1 is increasing. Bam, you get probably 2 points again for this one. Okay, now for part D, we're told we're told a line forms whenever a of t is greater than or equal to 400. We're then told the number of vehicles in line at time t for a to t to 4 is given by n of t equals the integral from a to t of a of x minus 400, where a is the time when a line first begins to form. And then it asks us to find the greatest number of vehicles in the plaza in the time interval. So please keep in mind, if you are asked for the absolute maximum or minimum, you need to create a table, and this table will need to include any relative minimums or maximums that you can decipher, as well as both endpoints, the bottom endpoint and the top endpoint. Why? Because when you find the relative min max by setting the derivative equal to 0, you're only finding the relative minimum and maximum. I'll give you an example where the relative min max isn't the absolute max. Well, look at this, right? Well, on this subinterval, the endpoint is the absolute max, okay? And the endpoint is the absolute minimum. And so there you need to check your endpoints. So what are we going to do? Well, first of all, let's determine this endpoint. So this endpoint is the point where the line first begins to form. So that is when a of t is 400. So I would write a of t equals 400. And then, so a of t equals 400. And then I'm just going to set that, I'm going to figure that one out here. So 450 square root of sine of 0.62 t. And again, you can't have a t. And then I'm going to get, I would set y equals 400. And so let's see when these two lines touch. And the first time they touch is at t equals 1.469. So that's a equals 1.469. And so then what I would do is you need to find the relative minimum or maximum. Here we're going to try to find the relative maximum by setting the derivative of the function that we're trying to find the maximum of equal to 0. So we need to find n prime of t. And so what is n prime of t? Well, we remember that the derivative is you just take this t value, usually it's the x value, right? But we're talking in terms of t right now, and you bring it down and replace whatever you had for your x's. So it's literally just going to equal a of t minus 400. And we need to set this equal to 0. We need to set the derivative equal to 0, and that will tell us the x values, and here I guess the t values, where we have our relative extrema. And so it is a coincidence here that we're going to end up getting a of t equals 400. So it's just going to be the same exact thing here. So one of the points is still going to be that, but we're also going to get 3.597 or 3.598. So t equals 3.598, right? And then after that, we're kind of outside of the range. We're only going from a to t to 4. So then you create a table, and this table has t values, and then it should also have the integral from 1.469 to t of a of x minus 400 dx, okay? And so our values are our bottom endpoint, 1.469, any relative extrema we had, so I'll put the 3.598, and then our top endpoint, which is 4, okay? And so I'm just going to evaluate this in my Desmos, right? So I'll do integral, and I'm going to say from, let's just type this in first, and then I'll put in my bounds. So we have a of t or a of x, so we'll have 450 sine or square root sine of 0.62x. Let me put this in parentheses, sine of 0.62x minus 400 dx. Okay, and so now let's set our bounds. So we're going to have 1.469, right? And then the first one is the integral from 1.469 to 1.469, and that's just going to be 0 because the integral from something to itself is 0. Then we would check at 3.598, and so we're going to get 71.25, and then finally we have to check at 4, right? So we're going to get 62.34, and so this looks like our maximum. Now be careful when you say the maximum number. It's not 71.25. Why? Because there cannot be 71.25 vehicles. Usually we're just going to round down because we can't round up. We can't add a vehicle. So we're going to say 71 cars, or 71 vehicles. If you put cars, they probably will give you the point. 71 vehicles is the most in line from, then you can just write A to T to 4, right? And so that should do it.